Hello again, and this time we're back at the guessing game, but this time I want to kind of talk about something a little abstracted away from the code itself. We will do a little bit of code, but I want to talk about planning. Before you get into writing the code, there's always some kind of planning phase that you need to get into, whether it's Agile, Scrum, or, whatever the format is that you can end up using, or if you're by yourself and you don't have a format at all, you just do what you do. So what I want to do is I want to think about a feature that we're going to implement, and then I'd like to implement it, but I'd like to talk about how I'm going to implement it before I implement it. That way I kind of show you an example of kind of how this works. One of the things I was thinking of was a difficulty system. So for this particular program, it's 1 to 10, but we could easily make maybe a medium, a hard, or an insane difficulty. And I think that'd be a great thing to do. And all we'd really have to do is change the range that the random int is generated. And then most importantly, let the user know what the new range will be. So kind of what I'm thinking of doing is kind of twofold. Obviously, we're going to have to add some variables to store the low and high, or store the difficulty and then check. There's a couple of ways we can do it. And what I'm trying to kind of get across here is the mentality or the idea that there's not always one way to skin a cat, as the saying goes. There's many ways that we can implement this. So let's think about this a little bit logically. So a difficulty system, as I said earlier, all we really need to do is change the range. Now we could create a switch, a bunch of if logic. Let's something like this. And then we could do and then we'd set up a second range. But then we'd have a bit of an issue in that when we come over here to our get guess, we do have a prompt that's hard coded 1 in 10. So we'd have to have some kind of display for that. We'd have to change it. And so we'd have a similar structure here where we'd be going, let's do this and whatnot. It's just not, it doesn't feel good to me, especially if you're trying to scale it to have a bunch of different difficulties, 2 or 3 difficulties. Not a huge thing in this small of a game. So with that being shown, that's just kind of one of the many ways. There's a couple of other ways I was thinking of using switches or changing some kind of values. But I think, honestly, the simplest way to do this, since the only thing we really have to change is the low and the high int. So that's what I think we should do. We should first implement some way to change the range that we're rendering, and then change that on the output as well in our get guess function. So let's go ahead and do, well, it was target. So let's go ahead and say low target equals 1, high target equals 10. Let's go ahead and line that up. All right, so now all we're doing is we're going to say self.lowTarget and self.highTarget. So instead of having the numbers hard-coded, we're going to be doing that. Now, as for this place, what I'm going to do is I'm going to break the strings here, and I'm going to say self.lowTarget. We'll make sure to stringify this. And then let's just go ahead and copy this little block here. And then we'll paste that in here with high target. And then, as you can see, quite the spread of numbers would be, it would take quite some time to get any kind of a match on that. So let's go ahead and implement a new function. This function is going to require user input. Let's call it set difficulty. And then I'm going to say here, I'm going to get rid of this little string here, and we're just going to say, please enter the difficulty you wish to play at. Okay, and of course add our, and of course add our colon there. That is pretty important. And now what we're going to do is we're going to need to have an actual difficulty. We need to set it. Our default will be 1. And then what I'm going to do is, instead of having an input here, I'm going to print 1 easy, 2, 3 medium, hard. There we go. So we got little output there that says 1, 2, and 3. Then it asks us to enter it. Then what we're going to do is we're going to need to take this and make sure that this is not guess, this is difficulty. Then what we're going to do is compare and check. We're going to say if self.difficulty equals 1, else if, and then we will do 2 elifs, and then else. So what we're going to do here is we're going to set our low target to 1 and our high target to 10. Our medium and our hard, we'll say elif self dot difficulty equals 2 and then 3. 2, let's make that 20, and 3, let's make that 30. Okay. Now what about this else? Now, what if the user inputs something weird at the very beginning? In this case, what's going to end up happening is if the user comes in and immediately presses the Q key expecting to quit, it wouldn't be able to quit or anything. So one of the things I could do is let's go ahead and tell the user that any other key quit. Okay, and then we will instead return false. Now let's go ahead here and let's run. We'll have to actually call this method. So we're going to say at some point we're going to want, before the game starts, we're going to want set difficulty. Then we're going to assign to a variable. We're going to return true. Okay. Then what we're going to do is we're going to set a variable. This variable is going to be diff set, or difficulty is set. Okay. And we're going to take all this and we're going to push it back a layer. So we're going to indent it. We're going to say if diff set, do everything else as normal. Otherwise, we're just going to fall through. So let's go ahead and take a look at this. You're going to see here, before we even get into the game, we've got this wonderful guessing game. Boom. 1, 2, 3. Easy, medium, hard, any other key, quit. Let's go ahead and do a big fat L. It quit. It's a good sign. Let's go ahead and hit a 1. Oh, it's quit. What's going on there? Well, what we're doing here is we're actually on our inputs. All of our inputs are strings. And so we're comparing against numbers. So we just got to stringify our numeric values there. So let's go ahead and put a 1 down. Oh, we're going between 1 and 100 here, guys. So let's try 0. No, whatever. You get the idea. So what was going on there? Why is this not set? Well, that's because I didn't set self. Remember, this is a great time to reiterate that when you're dealing with a class architecture, when you're inside of an object, you need to reference what it is that is the parent. You can have a variable called guess, target, win, difficulty, low target, high target in the class up here, or you can define a local one here. But if you need to differentiate between them, what you do is you use the self moniker. So this whole time we've been using self to reference the class itself. But anything outside of the class, anything outside of this instance of this object, we don't use self. Or anything local within the scope of that function or that if statement, whatever. So let's go ahead and take a look at it now. And hit our 1. We got 1 and 10. Let's go ahead and quit this. Let's run it again. Let's hit our 2. 1 and 20. Let's go ahead and see it at work. So let's guess 10. Let's try 12. Oh, it was 11. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Oh, wait, I'm way past 20. Again, I just wanted to show you that with the way that we've built this, if something is unknown, we don't know what the input is, and the user can put anything. A user can put literally anything they want, but we don't want our system to interpret that badly. So in this case, what we're doing is we're rejecting everything except for stuff we're expecting. And since luckily all we're expecting are numeric values, it makes things pretty easy for us. So let's go ahead and exit out. And let's go ahead and review this a little bit. What we have is we have a new function here. I need to put a little break there to make that a little more readable. We've got a new function here, which sets our difficulty, and it is a self-contained function. So it runs once here, and it runs before our loop, which we have now pushed behind this diff set. So what we're doing is we're setting it, and if we know that the setting was set, i.e. these happen, it will just go to the next command, which is return true. So it means all's well, return true. But if there's an input command that we don't recognize, i.e. we don't recognize it as string 1, string 2, or string 3, then we're going to say return false. Now, this function itself is self-contained. It doesn't care what true or false means or the context therein. Okay? I could rewrite this entire function to just simply return true at all times. Of course, we would lose our difficulty functionality, but the rest of the code would still function because it's still returning a value. In this case, we're just setting diff set to whatever the value of set difficulty returns. So that's going to be true or false. And in this case, we're just saying if diff set, which means if true. So if you leave out any value, it'll assume true is what you assume. It's going to assume true is what you decided to check for. So if you're just checking if it's true or if it's false, I can say this for if true, and then I would have to say the if false for that. So there you go. I hope you learned something. It was kind of an interesting thing. I've got a couple of ideas for maybe 1 or 2 more edits on this. I'm not sure if I'm going to do those right away or later. Probably later, give you guys a break on this stupid little program. But I hope you've learned something. You've gathered your thoughts on the class structure or anything. If you have any questions, just let me know. Leave them in the comments down below. And of course, as with all these stupid YouTube stuffs, give it a thumbs up if you liked it, and subscribe if you want more.